Hey guys, Miss Neat here. So I've got another 180 lesson for you today. It is Block 4, Topic 2, Lesson 4. We're going to be talking about adding fractions to find sums that are greater than 1. So we're going to be looking at what happens when we get an improper fraction and how do we turn that into a mixed number. All right, guys, so we're going to begin today with our do now. If we look at our do now, it asks us which of these fractions does not belong. So we have 8/12, 6/12, 2/3, and 4/6. Well, if I start with 2/3 and I look at 2/3, I can see that if I multiply 2 times 2, I get 4. If I multiply 3 times 2, I get 6, which makes these two fractions equivalent. So now I have to look at 6/12 and 8/12 and decide which of those is equivalent to 2/3 and 4/6. Some of you might already know that 6/12 is equivalent to a half because 2 6s make 12. But if you wanted to check it, you could say 2 times 4 is 8, and 3 times 4 is 12. Making those also equivalent fractions. So 2/3, 4/6, and 8/12 are all equivalent. That's going to be helpful today because as we add these fractions together, we're going to be needing to find equivalents to use common denominators. So if we go back to our previous lesson where we were adding together fractions with unlike denominators, we knew that we had to find a common denominator in order to add these. As you can see from the model, 1/2 and 2/8 can become 8 as a common denominator. But 1/2 has to be turned into an equivalent fraction. The equivalent fraction to 1/2 is 4/8. So if I grab my pen here, I can see the line right here. So these 1/8 size pieces are equivalent to this 1/2 size piece, and there's 1, 2, 3, 4. So I'm going to use an equivalent fraction of 4/8. That's going to give me an answer of 6/8, which I can then simplify to 3/4. So that kind of helps us see how this equation is used. So if we look here, this equation asks us to add 1/3 plus 1/3 plus 1/4 plus 1/6 plus 1/6. Right away, I can see that my denominators are not the same. So I'm going to need to find equivalents to each of those. So if I took that 1/3 and I put it up here, and I look at these other denominators, I can see that, well, 3 and 6 can share 6 as a denominator, but 4 cannot, because I cannot count by 4s and get to 6. But if I count by 4s, I can count 4, 8, 12. I can also count by 3s to get to 12, 3, 6, 9, 12. And I can count by 6s to get to 12, 6, 12, which makes 12 my common denominator. So the first thing I do is figure out how many 12th size pieces there are in 1/3. So I can use my model here and line them up, and I can see, oh, 4 1/12 pieces are equivalent to 1/3. So I'm going to rewrite this equation as 4/12 will be my first fraction, plus another 4/12 because I had 2 1/3 pieces that both had to be found as an equivalent. Now I can go back and look, and the next thing I have is 1/4. Well, if I take that 1/4 piece and put it up there, I need to see how many 12 size pieces. So I've got 1, 2, 3. So that 1/4 is going to be equivalent to 3/12. And then finally, I'm left with my 6th sized pieces. Now, when I put that first 6 size piece up there, that's going to fit just fine. I can now take my 12 size pieces and see how many of those I need. Well, I need 2. as I know, 6 times 2 is 12, and 1 times 2 is 2. So I'm going to add 2 12ths 2 times for each of the fractions at the top to complete this equation. Now, when I add these all together, and we know we only add the numerator and not the denominator, I get 4 plus 4, which is 8, 8 plus 3, which is 11, 11 and 2 is 13, 13 and 2 is 15. So I have 15 twelfths. This, my friends, is a fraction that is greater than 1 because the numerator is greater than the denominator, which means I need to turn it from an improper fraction into a mixed number. Now, if you remember, we had 15 twelfths as the sum of our equations. And we said that that was greater than 1. But let's show how that, in fact, is greater than 1. For this 1/3, we're going to put 4 twelfths up because that's what we used. So we've got 1, 2, 3, 4. For the second 1/3, we also have another 4 twelfths, which we added because we said 4 plus 4 was 8. For the 1/4, we said we needed 3 twelfths, so that's 1, 2, and 3, which gave us 11. And then for each of the 1/6, we said we needed 2 twelfths. Well, when I add my first 12th, I now have a whole filled in. So that's why this is a fraction greater than 1. I have to start a second model. So I add in the 2 twelfths from the first 1/6, the 2 twelfths from the second. And what am I left with now? I'm left with a whole plus a fractional amount. So if I write how many wholes I have in twelfths, I have one whole model filled, and then I have 1, 2, 3 12th size pieces remaining. So if I wanted to check and make sure this was in fact correct, 1 times 12 is 12, plus 3 is 15. I know this is correct. Is this in simplest form? No, it's not, because 3 and 12 can both be divided by the number 3. So this would be one whole still, but 3 divided by 3 is 1, and 12 divided by 3 is 4, because we know that 3 twelfths and 1/4 are equivalent because we changed them for our equation in the opposite way. We turned that 1/4 into 3 twelfths. This, my friends, is our answer, and it is in its simplest form. So if we were to do this again, we have 6 equations. We have 1/8 3 times. We have 1/4 2 times, and we have 1/2. Right away, I know I do not have common denominators here, but I know that if I count by 2s, I can land on 4 and I can land on 8. If I count by 4s, I can also land on 8, which makes 8 my common denominator. I do not need to change these 3 1/8 pieces then. They can remain 3/8. So I would just record them as 3/8. Now I have to take 1/4 and 1/4, which is 2/4, and I need to find the equivalent fraction to 2/4 that has a denominator of 8. So 4 times 2 is 8. I have to multiply the numerator by the same number, so 2 times 2 is 4. And 2 4s make an 8, just like 2 2s make a 4. So this is my equivalent fraction for fourths, leaving me with my 1/2. So I have 1/2. I again want a denominator of 8. 2 times 4 is 8. 1 times 4 is 4. Again, another 4/8. Oh, because 2/4 and 1/2 are also equivalent fractions. So now I can add these all up. 3 plus 4 is 7. 7 plus 4 is 11. And I have 11/8, which is an improper fraction. That means I need to turn it into a mixed number. So I can do this by drawing a model and seeing how I would fill the model, or models, because we know we're going to need more than one. So if I draw 2 rectangles, divide each of them into 8 halves, fourths, eighths. I then color in 11 of those eighth size pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can see that I have one hole filled in. And I have 1, 2, 3 eighth size pieces remaining. So my mixed number is 1 3/8. 1 times 8 is 8, plus 3 makes 11. And I am sure that this is completely done correctly. All right, guys, so I have modeled what's in the blue and number 1 on page 170. You also have numbers 2. In addition to the second page, which has 3 through 8 and your exit ticket. All of these are going to be practicing that same skill. You're going to be making equivalent fractions to find common denominators, use them to add, and then turn them into a mixed number because they are, in fact, fractions greater than 1. If you need any help, let me know. I'm here. And keep practicing those skills, and I will see you soon. Bye.